Hello, coding friends. So I released the previous video, which was about async work on the JSI, and I have already seen the first questions regarding crashes. So clearly, I did not communicate properly, or at least I didn't show you the more specific use cases where things will go wrong. So I thought that would just do a shorter video and just go try to explain to you a little bit more, give you a mental image, and then show you an example of something that might crash. So in the previous video, we had the async call. So we had a JSI or a C++ thread doing some async work, and then we would finally use the JS call invoker to do an async invocation back into JavaScript. And so I would just like to go over the mental model of how this is working, right? So if we start from the beginning, we start with our promise, which we have constructed on the C++ side. So I'm just going to start drawing here on my iPad, and let me see if that works. Okay. So here we have basically two worlds. We have the C++ world, and we have the JS world. Right now, the JSI being async, whenever the calls are async, then everything's fine, right? These two worlds are synchronized. We can access the data from both sides, or we can access some of the properties without worrying too much about incorrect memory access and racing conditions and so on. So first, when our, where's my Xcode? Did it crash? What happened to Xcode? Okay, that's weird. Man. It's weird that it's not showing. Okay, whatever. So whenever we have this first call, we're still on the sync land, right? So we are basically, here we create our promise from the JavaScript world. All right, so we're still fine. But then you have to realize, here we have created the code, we have created the callback, and so on and so forth. But you see immediately that we return this promise, right? So this promise gets returned into the JavaScript world. So your virtual machine, the JavaScript side of things, is just going to continue executing code, right? So it receives the promise, and it will just continue doing its thing, right? It will continue running React, it will continue to update the UI, it will continue to do other callbacks, and so on and so forth. So then, in the meantime, we have created the resolve function. Here, here's our resolve function, our reject, and this will start executing our code. And what we have done here is we have created our threaded work, right? So our thread, can I hide this? Technology is not happy with me today. Okay. So our thread will just start executing things, right? This is our task. We will start doing our computation while, at the same time, JavaScript is doing things. Now, the problem comes when we try to do something at the same time, right? So here inside of this task, what I have done here, I have just created a variable we'll call res, right? And this is C++, right? So if I do C++ things in the C++ world, it will be mostly fine, right? Like if I don't try to access some memory chunk that's being read at the same time or being written at the same time, everything will be fine. So what's the problem? If I here, for example, I would try to do something like JSI array, I don't remember what it is. Okay, create with elements, right? So I pass my runtime and blah, blah, blah. I just pass some data in here. What's going to happen is that my JavaScript machine is busy doing other stuff, right? It has its own stack, it has its own heap, and when I did this initial call, when I created my promise, the stack had a specific state, my heap had a specific state, but as time goes on, this will change, right? Like more things will be on the stack, more things will be on the heap, or something will change, this might not be here, and so on and so forth. And at the same time, it might be in the middle of some operation. So what happens? Here I'm going to try to create an array right at the same time where my JavaScript thread might be doing something else. Right? So this, if you get it to work, it's just pure luck, right? It means that the JavaScript virtual machine was not in the middle of some operation when you decided to create this. So it did manage to allocate some chunk of memory on the heap or maybe on the stack. It doesn't really matter, right? And then it returns to you your array. But this might also fail, right? Because you might try to write in some chunk of memory which was being used at the time, and so on and so forth. So let's assume for now you managed to create it, right? So you access the runtime from your C++ thread, it creates something. I'm just going to call this my res array, and then I'm going to capture this res array in here, and I'm going to try to return it to the JavaScript context. So also, what's going to happen? I have created in the array in here, right? Which means it's here on my JavaScript land, so to say. It's in a JavaScript virtual machine, but I am accessing it from the C++ thread. But this is an async call within a thread, right? So again, more time will pass, and here's where I have my execute async call. So again, this will change, right? The virtual machine will not stop for me. It will keep doing stuff. And what can happen is that my array might get deallocated, right? Because it has no reference on JS. It's only being used on the C++ side. Something else might have been put in here. It might have been rearranged. Doesn't matter, right? What matters is that these two systems are not synchronously, right, connected. They have race conditions. So what's going to happen is that when I try to do an async execution and I try to move it or something like that, it more than likely will crash. I mean, sometimes it might work if you're lucky, if the memory hasn't been touched, if the JavaScript machine hasn't deallocated your array, you might get lucky and this might work just fine, but it might be completely gone from your stack, right? So then your async or your execute async call, it's just going to crash because it cannot move this chunk of memory because it's not already there. It has been garbage collected, it has been moved, whatever, right? So this is the main point of using the call invoker, right? And this is one of the pitfalls of using threaded work. You have to understand the mental model. You have these two worlds of the native side, which is C++ or Java or Swift or whatever, and the state of your JavaScript virtual machine. Okay, so what's the workaround? Is you need to keep this part of the code, whatever was inside of your C++ task, in just C++, right? So the correct way of doing things is you receive, so again, this is C++, blah, blah, you receive your data, you receive JSI values, and you store them in native values. And by native values, I mean ints, I mean strings, blah, 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 which will only be C++ values, right? So then when you do the async work, these values might get garbage collected, they might be moved, they might disappear, it doesn't really matter. You have them on the on the, oh, sorry, I wasn't focusing. You have them on the C++ side, and you do all your threads. So you, again, here time will pass, your thread will start, you do all your operations on C++, right? So here again, JavaScript still doing its thing. And then when you are ready to go back into the JavaScript side of things, then you do your execute async call, and you turn your C++ variables into JSI values, right? Because this is what it does, the invoke async, it puts you in sync again with the JS world, right? So everything that's inside of this callback is once again safe to use the runtime once again, right? So if I here, for example, would like to have an array, I would do this is an std vector blah blah blah, I would just calculate my data, right? So 1 2 3, and once I'm inside of the async callback, here is where I would do, I want to create a JSI array, this is my res array, and then I would just go, this is not proper C++ code, don't pay attention to this, but I would just map my vector into a JSI array, and then I can finally return my res array, right? So again, here I will access the runtime in a safe manner, in a sync manner, because I know here it kind of gets frozen. I can create my JSI values, I can just return to them, and then my thread just ends. And here on this side I have a consistent state. All right, cool. That's all I wanted to show you. Hopefully that will make it clear for you. And remember to give a like, maybe subscribe, I don't care. But do try to follow me on Twitter. Thanks a lot.